Hi, welcome back, kiddos. We're winding down. We've got 3 of our 5 classifications done. We're going to move into double replacement reactions. Now, in a double replacement, you can kind of think of it as a wife swap, or trading dance partners if you want. So in this case, there'd be me and my husband, and Denzel and his wife, and of course we're going to trade dance partners, so I get Denzel always. All right, here's the key though: a cation must be with an anion when we do this. No anions with anions, because in science, like charges repel one another. They don't attract one another. Okay, so we're going to break these into 2 types. Precipitation reactions are going to form solids. There's more than this, but we're going to look at 2 types. And then we're going to look at neutralization. And in a neutralization reaction, we're going to be reacting acids with a base. And that's simply a subset of double replacement reactions. All right? Now, before we can get into that, we need to take a look at solubility rules. A double replacement, any reaction really requires some sort of driving force for it to occur. Now, that driving force can be the formation of either a gas. We're not going to be looking at those in too much detail. We'll see one in the lab, I believe. A gas, a solid, or a pure molecular substance, typically water. So those are our driving forces. So we need to be able to interpret. You do not have to memorize. You need to interpret some solubility rules. That said, it doesn't hurt to memorize the first 3 rules. It's pretty much what you need for AP anyway, for those of you who have the opportunity to take that with me. Now, let me help you understand how to read this table. What this first part is saying is that these are soluble compounds. In other words, they will form aqueous solutions. Any exceptions to those rules would be solids. So all group 1 salts, lithium, sodium, potassium, etc., those are all soluble, and there are no exception. There's no anion that you would put with that salt that would make it a solid or make it form a precipitate in the solution. All ammonium salts, ammonium chloride, ammonium nitrate, ammonium sulfate, all of those are soluble without exception. They will always be aqueous. So if you see those as your cations, they're always aqueous. These are some anions that you would need to know. Have an always rule. Nitrate, chlorate, perchlorate, acetate, always without exception soluble. Okay? Now, all chlorides are soluble, with the exception of silver chloride or silver bromide or silver iodide. It would precipitate. Mercury, too, is a very weird ion. It always comes in pairs. Mercury 1 always comes in pairs. And lead iodide. Okay? Those would all, whether these were iodide, chlorine, or chloride or bromide, these would all be solids. They would form precipitates. Okay, here's the rule for fluorides. That's why I said earlier that strontium fluoride was an insoluble. All of them are soluble except magnesium fluoride would form a precipitate. Calcium fluoride would form a precipitate. Okay, etc. All right, so the exceptions here all form precipitates. All right. Now, in the bottom part, it deals with things that tend to be insoluble. So insoluble means forms a solid. The exceptions would be aqueous. Honestly, you can get most of those except for the hydroxides by that top rule. Okay? So if a compound is soluble, it's going to get an AQ, assuming there's water present. Right, if there's no water present, like we saw one where we decomposed potassium chlorate to form potassium chloride and oxygen, there was no water present. So we said that was solid. As long as there's water present, if it's soluble, we give it an AQ. If it's insoluble, and we will see this in our lab, it will form a precipitate, and a precipitate is a solid that forms when two solutions are added together. So those are our solubility rules. Next, we will get into our double replacement reactions. So until then, this is signing off.